Welcome to this Algebra 2 session on imaginary numbers. We will be simplifying radical expressions that involve imaginary numbers, add, subtract, multiply, and divide imaginary numbers. So you may be wondering, where in the world did this concept come from about imaginary numbers? So, or even what is it? So an imaginary number, we denote it with an I. So that's the notation we use for imaginary number. And an imaginary number is equal to the square root of -1. So what this enables us to do now is take the square root of negative numbers. Before, back in the beginning lessons, we talked about when you try to take the square root of a negative number, you can't get a real number answer. You get an error on your calculator. Well, now we have something that will enable us to do that, to take the square root of a negative number. So where did it come from and what is it used in? You can look here and you can see where it came from, the mathematician that actually started the phrase imaginary numbers. And also, it's used in, you can see where it's used in electricity and in the study of electricity. So what do you need to know that's very important is you need to know that I, the imaginary unit, is equal to the square root of -1, and that I squared is equal to 1. Those are both a couple important things for you to know. And at any time, if you want to pause and write things down, just pause lower left-hand corner. So we're going to be taking the square root of -49. We couldn't do that before because we would get an error on our calculator if you try to do it on your calculator. But we can now that we have the imaginary unit. So what we do is we break the square root of 49 down into the square root of a positive 49 times the square root of -1. We said on the last slide that the square root of -1 is equal to I. So we can take the square root of 49 and get a 7, and the square root of -1 is an I, and that's our simplified answer. Let's look at 4 root -54. Well, we're going to break this down into 4 square root of -1 times square root of 54. I can put the square root of -1 last. It doesn't really matter, like I did up here. It can be in either spot. The square root of -1 is an I, so I have 4 times I times root 54. Now, part of simplifying that we learned before is that you need to simplify answers completely. You simplify square roots completely. So how do we do that? Well, we talked about before that your square root is not simplified if it has a perfect square factor, which the perfect square factor in 54 is a 9. So I do need to break this down further. So I'm going to break it down into 4 times I times root 9 times root 6. Root 9 is a 3, so I have 4I times 3 times root 6. Now, because of the commutative property of multiplication, I can rearrange the 4 and the 3 so I can multiply them, and I get 12I root 6 as my answer. Alright, let's go on to some adding and subtracting with I. It's a lot easier than you might think because we treat it just like a variable. So it's the same thing here as saying 2x plus 3x. Same idea. You add the numbers, keep the variable, or the I in this case, the same. So 2 plus 3 gives me 5, and I get 5I as my answer. You can take a look at, you can pause if you want to try the last two. 16I minus 5I. Subtract 16 minus 5, that gives you 9I. 4I minus 0.4I. I'm subtracting the 4 and the 0.4 to give me 3.6I. Next we're going to talk about multiplying and dividing, which does require a little bit more simplifying in some problems. 3I times 4I. I can, by by commutative property, rearrange this by multiplying the 3 and the 4 and the i's. 3 times 4 is 12. I times I is I squared. Now, if you have anything higher than an I squared, exponent-wise, you need to simplify it. So I squared or higher. we said before that an I squared is equal to -1. So I replace the, I'll put it down here, the I squared with -1, and that gives me -12 as the final answer. And last but not least, I'm going to divide -32i divided by 4. So that's just dividing the numbers, and you have the I here. So that gives you -8i as your simplified answer. There's no simplifying any further because we leave I. We don't replace the I with the square root of -1. We leave it as an I. Anything higher than I, though, we do simplify further, like I squared, I to the third, I to the fourth, and I'm going to talk about all of those next. So let's cover this up for a moment and look at this table here. This is showing you the powers of I and what they simplify to. So I to the first, of course, is just I. I squared simplifies to a -1, as you saw back in the beginning. I to the third simplifies to -I. I to the fourth simplifies to 1. I to the fifth simplifies to I. And notice we repeat the cycle of numbers over again. So how are they getting this? Well, I'm going to show you how they're getting it. And then I'm going to show you a shortcut way so that you can simplify any power of I that you're given. And it's from your lesson, and it's a good way to think about it. But I want to show you how they're getting this the long way. I squared, how do they simplify I squared to -1? Well, I squared we can write as I times I, which they didn't put in here, so let me just write that in quick. I times I, which is the square root of -1 times the square root of -1, which is the square root of -1 squared, and squaring a square root removes it, and you have -1 for I squared. I to the third. You're going to try and write I third as a power with a power of 2. So we can write I to the third as I squared times I, because this is I to the first. So I squared is equal to -1 times the I gives you -I as your simplified answer. I to the fourth is I squared times I squared. I squared is -1 times -1, and that gives you 1. I to the fifth we can write as I to the fourth times I to the first power. I to the fourth is 1 times I gives you I. And I to the sixth, we broke it down into I to the fourth times I squared. I to the fourth is 1. I squared is -1, and that gives you the -1. Now you could break these down in different ways. We'll try to do the shortened way of breaking it down, and these are your shorter ways to do that. Now, sometimes it's hard to think in this way of how to break them down. So your lesson actually gives you a way to do it that if you write these things down, makes it a little bit easier. If you notice back on our table, what they're saying here is that multiples of 4 give you a 1. Simplify to a 1. So I to the fourth is 1, I to the 8th is 1. If you kept this table going, I to the 12th would be 1, I to the 16th would be 1, any multiple of 4. So what they've determined that is if all you have to do to figure out anything that's not a multiple of 4 is divide that exponent by 4. And then they tell you you're going to get one of 3 remainders. You're going to get a 1 as a remainder, a 2, or a 3. If when you divide that exponent by 4 you get 1 as a remainder, then that will simplify to an I. So that exponent of I will simplify to an I. If you get a remainder of 2, that exponent of I will simplify to a -1. If you get an exponent of 3, then that power of I will simplify to a -I. So this is important, right? You want to write this part down. If you divide the exponent by 4 and the remainder is one of these 3. So before we go to these over here to talk about, let me talk about the ones on the previous page. So just look at I to the 6th. Divide, what this is telling you to do is to take 4 and divide it into 6. 4 goes into 6 one time, and you get a remainder of 2. So looking at our little list here, a remainder of 2 means that I to the 6th is going to simplify to a negative 1. So I to the 6th simplifies to negative 1. Let's go back and check it. I to the 6th simplifies to negative 1. So you can use this little rule here to figure out any power of I. So let's look at I to the 41st power. These are a little bit hard to see, so I apologize. Maybe I'll write them down here to work them out. I to the 41st power. What they want to know is what that simplifies to. So you take the 41 and you divide it by an exponent of 4. That goes in one time. And, oops, I'm sorry. Four goes into 1 0 times, and subtracting gives you 1. So we get a remainder of 1. So that means that I to the 41st power is going to be equal or simplified to I, because we got a remainder of 1. All right, let's try I to the 40th power. Oops, wrong color there. All right, so now we're going to do I to the 40th power. So you take 4 and you divide it into 40. 4 goes into 4 one time. And subtract and you get 0. And 4 goes into 0. Bring down the other 0 if you want. 4 goes into 0, 0 times. And we get 10. So we get a remainder of 0. So what does that mean? Well, 40 is a multiple of 4. So if you didn't know that, and you divided it out, you would see that you get a remainder of 0. So that means that I to the 40th, since it's a multiple of 4, is going to be equal to 1. So that's something you have to take note of too. If it's a multiple of 4, it's going to automatically be equal to 1. All right, then I to the 66th power. Oops. So if we take this to the 66th power, and then I actually am going to stop with this one because I have a couple more I want us to do. So take 4 and divide it into 66. 4 goes into 6 one time. Subtract, and you get 26. 4 goes into 26 6 times. And subtract, and you actually get a remainder of 2. I kind of ran out of room there. So a remainder of 2 means that I to the 66th power is equal to negative 1. So you get negative 1 here. All right, let's try one more, or a couple more I have here. I to the 17th power. Let's try that one. I to the 17th. So take 17 and divide it by 4. 4 goes into 17 4 times, leaving you with a remainder of 1. So that means that I to the 17th is equal to I. 120, if you didn't realize, is a multiple of 4. So 4 goes into 12 3 times, giving you a 12. Subtract, you get 0. Bring down the other 0. 4 goes into 0 0 times. So that means that it's going to be equal to 1, because it's a multiple of 4. And last but not least, let's do this last problem here. 4 over 5, 4i to the 4th divided by 5i to the 3rd. Well, we can't simplify the 4 and the 5, so they stay as is. I to the 4th divided by I to the 3rd, it's just like with variables. You subtract your exponents, and you get I. So our answer is either you can write it as 4/5 I or 4i over 5. And that ends the session.